1. Why sea ice cover around Antarctica is rising. GS Paper 3, Environment and Ecology. Why is it in news recently? A new NASA-led study has found the geology of Antarctica and the Southern Ocean is responsible increase in sea ice cover surrounding Antarctica. The researchers used satellite radar, sea surface temperature, landform and bathymetry, ocean depth, data to study the physical processes and properties affecting Antarctic sea ice. They found that two persistent geological factors, the topography of Antarctica and the depth of the ocean surrounding it, are influencing winds and ocean currents. These factors drive the formation and evolution of Antarctica's sea ice cover and help sustain it. Highlights of the study. The researchers analyzed radar data from NASA's QuickSat satellite from 1999 to 2009 to trace the paths of Antarctic sea ice movements and map its different types. They focused on the 2008 growth season, a year of exceptional seasonal variability in Antarctic sea ice coverage. Their analyses revealed that as sea ice forms and builds up early in the sea ice growth season, it gets pushed offshore and northward by winds, forming a protective shield of older, thicker ice that circulates around the continent. The persistent winds, which flow downslope of the continent and are shaped by Antarctica's topography, pile ice up against the massive ice shield, enhancing its thickness. This band of ice, which varies in width from roughly 100 to 1000 kilometers, encapsulates and protects younger, thinner ice in the ice pack behind it from being reduced by winds and waves. Older, thicker sea ice returns a stronger radar signal than younger, thinner ice does. They found the sea ice within the protective shield was older and rougher, due to longer exposure to wind and waves, and thicker, due to more snow accumulation. As the sea ice cover expands and ice drifts away from the continent, areas of open water form behind it on the sea surface, creating ice factories conducive to rapid sea ice growth. 2. Indigenous technology demonstrator of reusable launch vehicle tested successfully. GS Paper 3, Indigenization of Technology. Why is it in news recently? India successfully tested the launch of indigenously made reusable launch vehicle, RLV, capable of launching satellites into orbit around Earth and then re-enter the atmosphere, from Sriharikota in Andhra Pradesh. The technology, when developed completely, would launch spacecraft, including satellites, into space and re-enter the Earth's atmosphere withstanding extreme pressure and heat conditions and land in an intended spot. This would help us to cut costs on launch vehicles substantially. RLV is dubbed as India's own space shuttle. Objectives of recent demonstration reusable launch vehicle. To test the characterization of the aerothermodynamics of hypersonic flights. To test the autonomous mission management of hypersonic vehicles, and to test the necessary re-entry technology for the vehicles. What's the significance of reusable launch vehicle, RLV? RLV is the unanimous solution to achieve low-cost, reliable and on-demand space access. The making of the Indian Space Shuttle or RLVTD has taken 5 years and the government has invested Rs 95 crore in the project. This flight will test the capability of the vehicle to survive a re-entry at speeds higher than that of sound. The solution to reducing cost of launching satellites into orbit is to recycle the rocket or make it reusable. Scientists at ISRO believe that they could reduce the cost by as much as 10 times if reusable technology succeeds, bringing it down to $2,000 per kilogram from the present $20,000 per kilogram. Points to be noted. Scientists at ISRO tested the RLV technology demonstrator, TD, in the first experiment of its kind known as Hypersonic Flight Experiment. It was about 10 minutes mission from liftoff to splashdown. The purpose of the experiment is to help the shuttle glide over a virtual runway in the Bay of Bengal, situated 500 kilometers from the coast. The RLVTD is unlikely to be recovered from sea, Bay of Bengal, during this experiment, as it is expected that the vehicle will disintegrate on impact with water since it is not designed to float. The 6.5-meter-long reusable launch vehicle technology demonstrator, RLVTD, weighed about 1.7 tons. During the descent phase, small thrusters helped the vehicle navigate itself to the landing area. The final version will take at least 10-15 years to get ready.